Today we are going to be talking about several topics. The first is Dalton's atomic model. The second is atomic structure. The third is the introduction to the periodic table. The fourth is molecules and ions. And the fifth is naming compounds. Dalton's atomic model, which goes along with Dalton's atomic theory, states four main things. The first is that all matter is made up of atoms. The second is that all atoms of a given element are identical in mass and properties. The third is that compounds are combinations of two or more different types of atoms. And the fourth is a chemical reaction is a rearrangement of atoms. Dalton used all of these statements to create an atomic model. This proved that everything is made up of tiny atoms that are invisible. Atoms are made up of three components. The first is the electron, which is a negative charge, the proton, which is a positive charge, and the neutron, which is a neutral charge. In the nucleus, you have protons and neutrons, and on the outside, there is an electron field. Now moving on to the periodic table. The periodic table is an arrangement of chemical elements ordered by their atomic number, electron configuration, chemical properties, and their structure shows periodic trends. A period is a horizontal row, and a group is a vertical row. Elements are pure types of atoms. On this periodic table, the elements are colored depending on what type of element they are. For example, in the far right, you can see the noble gases are in purple. And in the far left, the alkali metals are in pink. When looking at elements on the periodic table, it is important to understand how they work. Atomic number shows you how many protons are in the nucleus of an atom. Valence shows the charge of the atom. The atomic mass is the mass of the atom. Isotopes are different forms of the same element, which have the same number of protons, but different number of electrons. Here are some key terms to remember.
'80s intro. Alright, molecules and ions. So here are some key terms, so be sure to write some notes down. Firstly, you have chemical bonds, which are forces that hold atoms together. Then you have covalent bonds, which is the sharing of electrons. Then you have a molecule, the resulting collection of atoms after atoms bond. And there are two ways that this can be represented. The chemical formula, which is what you're probably going to use more often, and then the structural formula, which you're going to use later in the year. That gets fun. Let's get to the ions part of molecules and ions. Here are some key terms. Ion, an atom or group of atoms that has a net positive or negative charge. A cation is a positive ion. Here's an example. Write it down. Then here's an anion, which is the opposite. Therefore, it is a negative ion. Example B. Then, since opposites attract, you have ionic bonding, which is the force of attraction between oppositely charged ions. Keep taking notes.
Today, we're going to be talking about naming compounds. So, we know compounds are a combination of two or more elements to form a new substance. So, basically everything in the world is made up of compounds. For example, salt, or NaCl, and stomach acid, or HCl, are things we encounter every day. But why aren't these names enough? Why can't we just call them salt and stomach acid? Well, scientists use these special names to tell us something about the composition of the compound. So it's not just salt and stomach acid, because those things don't tell us what it's made of. So, the first type of compound is an ionic compound. The formula for this is a cation. The cation, for the positive ion, keeps its normal name, no change. And the anion keeps its normal name, but with the suffix "ide." So, for example, NaCl is sodium because of the sodium, and chloride because of the chlorine. Again, Bei2 is beryllium iodide. So another thing is some of these elements can form more than one cation. For example, the ones listed below. And this is based off of the fact on what the charge is of the ion. So for example, Fe in the first situation has a charge of +2. So it has iron with the numeral 2 bromide. So you can see FeBr2, the Fe, in order to match the Br, has to have a charge of 2. And same for this one, except it has a Roman numeral 3. Polyatomic ions. So this list is very important. You're going to want to pause this video right now just to survive AP Chem in general and list these all down, color code them, do whatever you want. So yeah, I'd do that right now. Take a short break. But what these are for, and when you're using these in a name, they're often going to be, at the end of naming a compound because many of them are anions. So you just keep the normal names. It's pretty simple. So again, take note of that. All right. Next, we have covalent compounds. So it's basically the same, but with prefixes, which is interesting. And you can see my little list right here is the different prefixes based on the number that is associated with the element. So, for example, PCl5 is phosphorus pentachloride. As you can see, PCl5, phosphorus pentachloride, because of the 5. CO is carbon monoxide, because there's one O. Now, the important thing to recognize is mono is never used for naming the first element. So it wouldn't be monocarbon monoxide, just carbon monoxide, because carbon sounds silly. All right, the third type is acids. And acids, if you don't already know, are an H+ ion attached to an anion. So, if the anion doesn't contain oxygen, it just ends in "ide." And the hydrogen is hydro, has a suffix of hydro and a suffix of "ic." So HCl is hydrochloric acid. And HCN is hydrocyanic acid. Now, things change if the anion does contain oxygen. That's when it gets real interesting. So, if you look back on your polyatomic ion sheet, sulfite, it ends in "ite, and some sulfate ends in "ate." So if it ends in "ate, you change the "ate" to an "ic. And if it ends in "ite," then you change the "ite" to "us." It's simple, as long as you remember that. But as you can see at the top, which I realize I'm blocking now, but you can kind of see it on the bottom, it changes to, here, I'll list the examples right now. HClO4 is perchlorate, so it would be perchloric acid. And as I'm now describing on the bottom, HClO4 is chlorite, so it would be chlorous acid. And as you can see, hypochlorite is hypochlorous acid. Thank you.